Welcome back. We learned to join a streaming data frame to a static data frame in the previous lecture. Joining a stream to a static data frame is a stateless operation. Spark does not need to maintain any state for such joins. Why? The answer is straightforward. The state is required when you do not have the information in hand and you are expecting it to come in the near future. For example, aggregates. When you are computing aggregates, you do it for one micro batch. However, you do not know if you received all the input values. They might come in the next batch, right? So the aggregate which you computed for the current micro batch is not final. It might update depending upon future records. Hence, Spark will keep the aggregates in the state store and update it again when a new record arrives. Similarly, when you are joining two data frames, you may have one of the following situations. In the first scenario, one side of the join is fully known. Why? Because it is a static data frame. And you have all the information you need on the static data side. Hence, you can perform the join immediately. We do not have to keep something in the state store for future use. However, in the second scenario, both sides of the join are partial data frames. Let's assume you have a record A on the left side, but record A is not present on the right side. So, you cannot join them. However, you cannot discard the left side record. You must keep it in the state store. Why? Because if the next micro batch brings record A on the right side, you must join it. The point is straight. Stream to stream join is a stateful join. Spark buffers both sides of data in the state store and continuously checks for the match as the new data arrives across the micro batches. Let's try to understand it in more detail with the help of an example. Let's assume you are a big news portal. The primary revenue source for your company is coming from online advertising campaigns. You run advertising campaigns for your customers by placing display banners and adverts at specific and predefined locations on your web pages. These locations are known as advert inventories. Each time you show an advertisement on an inventory, you call it an impression. Each impression on your website also goes as an event to your Kafka topic. The impression event looks like the following. Once the impression is in place, your website visitors might click on these impressions. When a user clicks an impression, you again generate an event and send it to Kafka's topic. A click event looks like the following. Now, you are asked to match these impressions with their clicks in real time. Once these impressions and their respective clicks are matched, you can perform a bunch of other analysis such as computing campaign performance and click-through rate, etc. However, the first step is to match the impressions with their clicks. How will you go about solving this problem? The solution looks simple. Create one streaming data frame for the impression and one more data frame for the clicks. Then you can join them on the inventory ID. Make sense? Let's do it. Here is my starter project. I am creating a Spark session, defining impression and the click schema, reading impressions topic from the Kafka, and extracting value to make the impression data frame. That's all. We have a streaming data frame of the impressions. Similarly, I am reading the click topic, extracting value to create the clicks data frame. You learned all this in the earlier lectures, right? Now we have two data frames. All we need to do is to join them. So let me define the join condition. Here it is. Simple, isn't it? We want to implement the inner join. So let me define the join type. That's all. Let me join these two data frames. Join is straightforward and we do it in the same way as we do for standard Spark data frame joins. We do not have any special syntax for streaming data frames. Done. What is next? Now we can create and start the streaming query. I'll start with the join data frame, call the writeStream method, and set the format to console. What should be the output mode? Do you want to use the update mode? Well, update mode doesn't make any sense for a plain join. Why? Simple. We do not have anything to update here. Either the record is joined or it is not joined. Once it is joined, we do not have any further updates to the record, right? So let me use the append mode. The append mode makes a perfect sense here because each record comes out only once after the join happened. Make sense? The rest is all the same. I'm setting a checkpoint location and also setting a trigger. Then we start the query and wait for completion. Done. Looks like a simple thing. However, we have a bunch of gochas in it. Let me run it and show you some observations. I'm starting Zookeeper and Kafka. Creating impressions topic and also creating clicks topic. Now let me start the impression producer. Then we start the clicks producer. Now I will send 2 impressions. The first impression ID is 101 and the second one is 102. Then we send a click for 101. Let's start the application. What do you expect? I'm expecting 101 in the output because only 101 impressions were clicked, right? Here is the output, as expected. Now let me click the 102. We got another joined record. So the impression for 102 was kept in the state store. When we clicked the 102, the impression 102 was matched and we see the joined record in the output, right? All looks good, isn't it? What if 101 is clicked once again? Let me send one more click. What do you expect? Impression 101 should be matched once again. It is as simple as one-to-many join. So it should also work, isn't it? Well, it is working. But what does it mean? It means all the records are kept in the state store. Even if we got a successful join, records are still kept in the state store looking for one-to-many join opportunities, right? And more importantly, it is not only the impression, but clicks are also kept in the state store forever. Let me show you. So as of now, we have 2 impressions in the state store, 101 and 102. How many clicks did we send? 3, right? We sent 101, then 102, and then we sent 101 again. What if 101 impression comes again? Well, in a real business sense, impression events should happen only once. It should not repeat. However, we are not using an impression ID in this example. We are using an inventory ID. So an inventory can have one more impression, isn't it? What if I am sending one more impression? Let me send it. I'm sending one more impression to inventory ID 101. What do you expect to happen? We have 3 clicks in the state store. 2 of them are for 101. Both of those will now match with the second 101 impression. Here is the result. This simple demonstration should bring 2 important points to your notice. The entire stream from both sides of the join is kept in the state store. And Spark does not know when it should clean the records from the state store. Duplicate events will cause logically incorrect joins, and you cannot blame Spark for doing this. So be careful when you are modeling your solutions. In this example, we should have given a unique ID to each impression. Using inventory ID will cause duplicate impressions, and each of those will join with all the previous and future clicks for the same inventory ID. How do we deal with these problems? We will learn about the state store cleanup in the next video. However, the second problem is the design and the modeling problem. I brought it here to make sure you understand this common problem and consider it when designing your event data models. See you again. Keep learning and keep growing.